Right. So right now we want to conclude our Unit 3. We did a little bit of functions, a little bit material that we covered on functions. But right now we just need to finish it off so that another lecturer will be taking you guys from next week onwards. So this is what we're going to be covering: functions, the features of functions, that is modular programming, reusability and manageability. Then we're going to look at the basic terminology that is used along with functions. That is the naming conventions of functions, the arguments, the return value, the function definition, invocation. We're going to look at 3 different types of functions, and we are just going to look at different types of implementing searches. And most of this material you cover it next semester when you do data structures and algorithms. We're also going to look at the variable scope, the life cycle of a variable in and outside a function. And we'll briefly look at recursion, the rabbit problem, that is the Fibonacci series of numbers, and the disadvantages of using recursion. Then we'll cross over to iterators, generators, and comprehensions. We'll look at the power of using the for loop. You can use it for lists, for dictionaries, for tuples, for strings, for working with strings as well. Then defining iterable objects. Some of the material will not cover because you need to understand more about classes and objects before you cover that one. So we're going to skip some of the parts, and another lecturer will take you through. So basically, what is a function? I'm going to go to the textbook. This is your textbook, Unit 5. Functions are covered in Unit 5, so we're just going to run over and look at how the gentleman described functions. Functions are units which perform a particular task, taking input and returning output. Right? That's what functions do. And these are the features of functions. Modular programming. If a program is divided into small parts in such a way that different parts each performs some specific task, then each part can be called as per the requirements. Zvakanaka kuva modules, right, in your code. It makes it easy to understand the code. Let's say you are writing code without a structure, without functions. That code will be difficult to understand. Let's say you are the lead developer, and then you get another job right in the middle of the project, and that the project, maybe let's say it was halfway or 75% complete. It will be difficult for the programmer who is going to replace you to understand that code. So if the code is divided into functions, that is modular programming, it becomes easy for the next person to understand your code. Reusability of code, it makes it easy for you or another programmer to reuse the code that you would have written, because munanenge akungoita invoke that function that you would have written, right? Manageability, it's easy to manage, and manageability is divided into 2 parts. That is, kana tichitaura nyaya manageability, we mean the code is actually easy to debug. It's easy to find errors. You know that this error that we're getting, it's in the function yekuita that particular task, right? Or 3 functions have got errors. It becomes easy to locate and debug your code, and it makes code efficient because you can target each function you want to target and try to maximize code. Just code optimization, right? To optimize code within a function, right? So that maybe the processing becomes a little bit faster, so that you yield your results quickly, right? So that's all about features of functions. And this is the terminology of functions. The name of a function, you have to write the name of a function. And I also talked about my arguments. When you are defining a function, this is the way that you use def, right? Then you write the name of the function. For example, function 1, right? Function 1, then full colon. Then you enter automatic indentation, right? Then you print what you want to print here. We are in function 1, right? That's just an example. Right, let's go back to our book. The name of a function. Then you can also have arguments. Arguments are the variables that you define within the parentheses of a function, right? So a function has got the keyword def, it has got the name of the function, and it can or may not have arguments. Like in this case, this function doesn't have arguments, but we may choose to have our own arguments, right? So A and B, they are just variables, and these are examples of arguments. And it's not cast in stone that you should write A and B explicitly. You can give any name of your choice. You can write Sadza, you can write Masango, Dewere Tsoko. You can write that, right? You can write any name of your choice. Where do we? And we also have return value. Let me give you an example of a function that returns a value. An example of a function that can return a value. Def, right? Add me, right? A, B, right? Then ta, enter. Then we can create another variable. We can call it result is equal to A plus B. Then return. When you return something, you write the word return. Return is the keyword. Then after return, you write whatever it is that you want to return, right? Right? Result, right? Right. So when you want to invoke the function now, you have to write the name of the function. Add me. Then you have to really write the numbers. You have to feed in the numbers in the parentheses, right? This is how you do it, right? So we created our function, and it is returning the result of A plus B, which is 9. 6 plus 3, 9, right? What else do you guys need here? They are talking about the same thing that we did here. This is invoking a function. Parameters are just the arguments, right? They are separated by commas. That's what we did. And you can put any number of parameters you want here. You can put another extra here. You can do whatever you want, my guy, right? Now this will generate an error, which means you should when you invoke a function, you should put the same number of arguments that are in the function definition. So this is the function definition. It has 3 arguments. So when you invoke it, you should also put 3 arguments. If you don't put 3 arguments, if you put a different number of arguments, then you generate an error like this: missing one required position argument C, right? So if I run this, everything is spick and span. Let's see what is left here. The body of a function. Basically, this is the body of the function. This is the body of the function. What's left? Mamma mia. These are just examples. These guys were also, he did something, Ecclesiastes, blah blah blah. So we're going to look at different types. Basically, we have 3 different types of functions. Number 1, 3 different types of functions. Let me just write something here. Types of functions. Types of functions. So the first type of function that we want to discuss is the function that has got 0 arguments, and the function won't be returning anything, right? So we can take this for example. take this one, for example. Let's modify it, right? So this is a function. This is the first type of a function, right? It takes 0 arguments and it does not return anything. That's the first type of a function that we're talking about, right? If we just run it, we are in, oh, sorry for this one. We are in function 1, right? So this is the first type of a function. Then the next type of a function, this is the function that is arguments but does not return anything. So we can take this one. Let's say this one has got an argument A and B, right? Then if we want to run this one, we have to put in some arguments, and the arguments are not associated with any data types. They are open. That's the advantage of Python. You can define you can declare a variable, right, without necessarily explicitly pointing out the data type of that argument, right? It can be an integer, and it will be up to you when you implement the function. You see, A and B, here we implemented them as strings, but they have nothing to do with the body of the function whatsoever. Now then, the last type of a function is a function that has got arguments and yet returning something. For example, this one, this is the third type. It has got some arguments and it at the same time it's returning something. So basically, that's what you need about the types of functions. And that's the advantage of arguments, right? Unokwanisa ku declare arguments ako without explicitly pointing out the data type, right? We saw that example. So this is just an example of implementing a search, right? Most of these search algorithms, we're going to be doing them next semester, but data structures and algorithms. So forgive me if you don't understand what I will explain here. Did it? So what this function is doing is we have got a list of numbers, right? And from this list, we want to search. What we want to search is we want to search 5. Did it? We want to search 5, right? So what we do is we create a function called search, and this function takes 2 arguments, right? And we're going to have a loop, and this loop is going to loop through the list. And you remember loop amna list, it's not for I in L, which means it is going to loop through this list, right? Then as it begins to loop, we have got this flag variable, right? Panotanga kusecha, we switch it on, right, by assigning 1, right? Kana in a 0, it means it's switched off. Then we have to print the position of I, right? We have to print the position of I. So if I is equal to item iri kusecha 5, kana I ari 5, then position ya I ndiyani? Number yatiri kusecha iri paposition ipi? Then takuti if flag is 0, print not found, which means kana flag ikaramba iri 0, which means the value that you are looking for does not exist in the list. Such that panozo, this is the invocation of the function. Takuti search number 5 in list. Then panapa yakunzichi position 5. In fact, 0, 1, 2, 3, 4. This might not be true. We'll check this code again. But basically, in a nutshell, that's what it really means. Don't want to go code